Good morning, Ankita. Have you got the data set for the random forest implementation, CTG, no? Okay, let's start. So this is the data set that we have, CTG. And there is also another file, CTG features. So we can look at this file also. So this basically describes the data set. Okay, what are each of these features? So we have baseline value, AC means accelerators. You can see here. Okay, these are the column headings. So FM means fetal movement, UC is uterine contractions. Okay. And what we have to predict is the last variable, which is called NPS. Sorry, NSP. Okay, normal, SS symptom. Are you able to see the three names? N is normal, S is symptom, and P is pathologic, I think. So that's the three level of the disease. For some reason, I'm not able to see those three values. Just check the text file that you have. Is it given? What is the full form of NSP? So I think I have the old text file. So normal, suspect, and pathology. So that's a severe case. S is the suspected case. That means there could be signs of that disease. Okay, and N is healthy person. Okay. So based on all these factors, we have to do a classification whether a patient or whether a person is likely to be suffering from the CTG syndrome. Okay, so this is related to the heart. So what kind of a classification problem is this?
More than 2 classes.
More than
2 classes.
So what is it called? Two classes, what do you call that? When there are only two classes to predict, it is called binary classification. More than two?
Not binary.
No, not binary, it is multi-class. Okay. Not binary can also mean one. So it's not, it is multi-class classification and binary class. So here we have an example of a multi-class classification. How do you evaluate a multi-class classification?
Based on number of attributes.
Evaluating the model, that is. How do you evaluate a multi-class classifier? Have you done any multi-class implementation? I think we did it. No? How do you evaluate a binary class? Correct. So how do you evaluate a binary class? Same applies to multi-class also. What are they?
Correlation.
Evaluation. One minute. Evaluation means how good the model is. Okay, that is evaluation. So for a binary class, how do you evaluate a model? First is we plot the not plot, we find the accuracy of the model. Then we draw the confusion matrix. Then we have the classification report. So classification report gives you the value for precision, value for recall, and value for F1 score for all classes. Okay, so this is binary. Now, apart from this, you also have ROC curve and the area under the curve, which are drawn together. So this will also determine the goodness of the model. Now, when you are talking, when you are doing a binary classifier, what is the first thing that you need to determine in a binary classification? Let's say that I have a Y variable, which gives you only two values, isn't it? For example, I want to find out whether a person will get a loan or not. Okay. So here I'll have the variable as get loan or no loan.
0 and 1.
Okay, 0 and 1. So the 0 and 1, what do you call these values? 0 and 1. What are they known as? They are known as the positive class and negative class. Correct? So positive class means what you want to predict. So for example, I want to predict if a person will get a loan. So I want to call this as a positive class. Person who does not get a loan, that automatically becomes the negative class. So when I'm drawing the confusion matrix, I will have four measures. What are they? True positives, true negatives, then false positives and false negatives. So based on all these four values, I get my overall accuracy, I get my precision, I get my recall for the different classes or for the two classes. Now, when I'm talking of a multi-class classifier, what is the positive class? What is the negative class? Now, in this example, so let's take a very simple example. You have, okay, we'll take the same example where NPS, okay, so normal, suspect and pathology, okay, or NSP, I'll take this. Now here, what is the positive class?
We might drop one class and then decide positive and negative between two classes and the remaining is also.
Okay, so that is one way to do it. Okay, so that is called as OVA or one versus all method. But here we won't be doing the OVA method. We can directly use the multi-class classifier. Now the difference between yes. What's your name? Okay, you are in the wrong class.
Okay.
See Bob is upstairs or this.
Oh, thank you.
उसको बिठाना था ना. You be wondering ये क्या हो रहा है? Multi-class, binary class. Yeah. Oh, this is interesting. Banking में ये भी है. Anyway, okay. So multi-class and binary class, what is the main difference? There is a positive class, there is a negative class in binary. Okay, but whereas in a multi-class, there is no positive and negative class. Okay, now if I say NPS, there is nothing called as a positive negative. Okay, so my evaluation will be done based on how many N's get predicted as N. Okay, so this is considered to be as true positives. Okay, there are 20 people who are normal. I want as many N as possible. So that is true positives. Now, N can be misclassified as P, N can be misclassified as S. So these are known as false. These are false predictions. Okay. Similarly, P classified as P is positive, whereas P classified as N or S are negative. Okay. Similarly for the S class. So S classified as S is positive, and S classified as P or S classified as N is negative. Okay. So when I'm looking at the overall evaluation, I will have three classes. One is S, one is P, and one is P, and one NSP. So I'll have the precision, I'll have the recall, and then of course I'll have the F1 score. So how many normal has been predicted as normal? Okay, so precision is what? How many total records predicted as normal, out of which how many actual normals? So that is precision, that is recall. So similarly for S and similarly for the third class. Okay, so this is the evaluation metrics for a multi-class classifier. And how will the confusion matrix look? So here I'll have a 3x3 matrix. Okay, so NPS, NSP, actual, and then NSP predicted. Okay, so how many N I have in my testing data? So let us say I have actual data is 25, total data for S is 30, and this is 10. So total is how much? 5. This is 65. Now let's say that the prediction out of 25, how many are predicted as N? So let's assume this number is 20. Okay. Now, if this is 20, what about the remaining 5? They can either be predicted as S, or they could be predicted as P, or a combination of S and P, correct? So I can distribute the 5 records as 0 and 5, or I can distribute this as 1 and 4, or 2 and 3, or 3 and 2. Okay, any combination, so that it adds up to 5. So let's say that I have the predictions like this, 2 and 3. Okay, so actual data is 25. Okay, actually I have put it in the wrong place. So predicted is 2 and 3. Fine. Now we'll come to the second class. Out of 30, how many S is predicted as S? So let's say this number is 22. So that means the remaining 8 is either predicted as N or P. Okay, so 8 can be distributed like this. This can be 6, this can be 2. Clear? Now, which is the last class? P. So out of 10, how many P are predicted as P? So let's say this value is 7. So actual is 7, actual P is 10, predicted P is 7. So the remaining 3 are either predicted as N or S or combination. So if I put 2 here and 1 here, so it adds up to 10. Now, what is the total number of predictions for N? Total predictions, 25. Total predictions for S, 30. Total predictions for P, 10. So this adds up to 65. Actual data adds up to 65. Now, which is the true classifiers? What are the true classifiers or the correct classifications? Which are the correct classifications? The diagonal ones. Okay. So if you look at the diagonal, these are the correct classifiers. इसको क्या बोलते हैं? True positives. Fine. So the confusion matrix looks slightly different in a multi-class. In a binary class, it is 2 by 2. Here it is n by n. N is the number of classes. Clear? So let's go to the hands-on. Okay, just one more thing and then we'll do the hands-on exercise. So in the y variable, I have 3 classes, N, S, and P. Now, can you tell me, there is in the EDA stage, we find the distribution of the classes. Distribution of the classes. Okay, how many N's are there? How many S we have? How many P's we have in the data? So what is the need for finding the distribution? Sorry, accuracy.
What percent they are accurate, the actual N's and the predicted?
No, this is with respect to the data. Let us say I have 50 records. Okay. So out of which N, let's say, is 25, S is 20, and P is 5. Sorry, 15. No, 5, correct, no? What is the use of finding the classes distribution?
Measure of dispersion. Measure of the dispersion.
Measure of dispersion on a categorical data. This is a categorical data. No? I'm finding the count. Okay. So if I have the count something like this, 20, 15, and 15, will it give me a good model always? This is almost similar. Okay. So one thing is we want to find out the percentage of distribution. Is it normal? Is it even or not? Okay. So that is one. Now, if it is not even, suppose it is like this.
So there are only 5 for T. The total for T is only 5. So the output will be more in favor of NMS as compared to B.
Okay, correct. So we can have a biased
Bias.
one. Okay, so that is one thing. Any other thing that? So let us say the distribution is something like this: 28. Not 28. We'll put 27. 21. This is N S. Suppose my distribution is like this.
It won't predict that.
It won't, it can predict.
For P, it will not give that much accuracy.
Okay. Now what can go wrong here?
In testing data, if we split the data, either there can be possibilities of 50-50% split, or 2 can go in training and 0 can go in testing.
We discussed this, isn't it, in the class? So when you have a minority class, a very small number, so when you split the data into training, testing, so training and testing, so here it can be 2, here it can be 0, so which is okay. Here I can have 1, here I can have 1, this is okay. Here it is 0, here it is 2, this is not okay. Okay, so we need to find the count of the classes in both the training and testing to ensure that the class is existing in both. Okay, otherwise you can have a problem where the the model is trying to predict a class which is not understood by the model. Fine. So now let us, okay, one last thing. What is the type of data that we have here? Numeric data. So what are the things you should remember when you have a numeric data in terms of EDA? Nulls. Singularity is okay. Correlation, very good.
Not inequality can be removed.
He said that.
Feature selection.
That will correct. Aaj Tejas mood pe hai. Very good. Yes, what else? Outliers are, yesterday what did we discuss? Yes, outliers important in random forest? Not really important, but as a analyst, we have to take care of it. Any other thing with respect to a numeric data? Check for 0. See, here you can see some values which are 0. So is 0 a valid value or an invalid value? Okay, that is something that you need to understand based on the domain. If you understand the domain, then you can make out is 0 valid or it's an error. Now, one more thing you can do is transforming this data into a different form. Okay, for example, log form is a transformation. Inverse is a transformation. Min-max is a transformation. Okay, Z-score is a transformation. So you can consider transforming the data in case you feel the data is not giving me a good result. But usually for random forest, we do not do the transformation type. That is meant only for regression or KNN that we see later on. But if you want to do some research and find out if it makes any difference or not, you can do a transformation of the data. Okay. Okay, so let's get started. We'll go to Python. So we have a multi-class classification. So we'll start with the libraries first. So from sklearn.ensemble, we have random forest classifier. Then grain test split. Then from metrics, we have accuracy score and classification report. So put the path, what you have in your system. So here we can see that data has been read. Okay, now you can find out the dimensions. So CTG dot shape. So there are 2,126 records and 22 features, 21 features and one Y variable. Now imagine using a decision tree for this. Okay. It's quite a substantial number, isn't it? 21 features. So if I build a decision tree, there is a chance that it is going to overgrow and it is going to overfit. But again, just based on theory, we cannot say. You have to actually implement it and see how the performance is. Okay. So I leave that as an exercise for you to do. After the random forest, take the data as it is and implement decision tree and see how the performance is. So create a variable for columns, store the column names. Columns equals CTG dot then you drop the Y variable. Now there is there's a purpose behind storing these column names. Can you tell me why?
We have to get multiple histories and the conditions.
Even before that, we did something similar in regression.
Check the type.
Type, I can do it. I can just do CTG dot types. Why do you need the column names without its dependent variable?
X variable. Create X variable.
We have X. These are the features.
To understand which the root split.
That will be done under the inside the algorithm itself. So we need not do that calculation. This is for the multicollinearity check. Okay, this is a numeric data. So we need all the features. Okay, since everything is a numeric data, so we take only those columns which are numeric columns. So here everything is a numeric column. Okay, if you look at the data types, so we'll take only the features minus the y variable and do the multicollinearity check. Okay. So we can write here, check multicollinearity. Next, we'll just do a quick EDA. So check for nulls and check for 0. Now, if there are any zeros in the columns, should we fix them or should we leave them as it is?
We have to check to understand the data.
Correct. Okay, you have to understand the column first, whether it can take 0 or not, because not every 0 is a bad value. Sometimes you can also have the data as a category, but it is listed as a number. For example, 0, 1, 2. Okay, it is actually a categorical data. You need to think in terms of whether it is a valid one or not by looking at the data and understand if it is valid or not. Okay, blindly don't impute. So check for nulls. So ctg dot is null. And set. So there are no null values, which is good. What about zeros? So I can do ctg equals 0. So you can see there are lots of columns that have zeros. AC has 891 records with zeros. FM has 1311. UC has 332. So you need to understand, are they valid zeros or are they bad values? Now, out of all the zeros that we have, there could be some columns which are categorical. Okay, even though it is listed as number, they can have only limited values, 0, 1 or 0, 1, 2, something like that. So a thorough analysis is required before you can proceed. हो गया यहाँ तक तेजस? All done? Okay. Ankita, any questions? Okay. So I want you to do this exercise. Plot the heat map to check the multicollinearity. So do this exercise and then we will proceed with the model building. लीनियर रिग्रेशन में मिल जाएगा वो उसका रेफरेंस. हो गया डन डाउट्स हाँ बोलो हाँ all equals all got remove वो remove करके automatically assign अपने explicitly assign किया तो वो null करता है so remove function will remove and update automatically.
The function which you gave in linear, I just copied and pasted it. So now how to edit the figures? Fix it, the graph. It is like
don't take the full thing, just take that multi. Take only this. Use the PND plot. The figures. Did you use the trill function? TRIL, the lower triangle. Otherwise, you will get the entire area filled with numbers. Okay, you can use the TRI triangle lower. Remember, lower triangle, upper triangle. So you can use the NumPy. Import NumPy as NP. And then np.tril COR. Now, if you look at this, this is an n by n matrix. Okay. Now, after I do the trill, it will be filled with only the lower triangle, upper triangle will have 0. Okay, so it is easy to read. Right? So columns we already have. Now you can simply use the SNS. I'll also import that. So import matplotlib dot pyplot as PLD. Import cbon as So these are some settings that you can do on the graph. Okay, before you plot the graph. So RC parameter is going to set the figure size. You can use fixed size. Whatever number that you want to use. Now the use of the font scale is, we have close to 21 features. Okay. Now if I take the default font, it is going to spill over to the next cell. So I'm reducing the font size so that it fits into the cell. Okay, so I'm reducing the scale to a smaller number. Now you can use the regular SNS.heatmap. The first parameter is the matrix. Then X tick labels equals columns. Columns. Let's reduce the font a little bit. Much better. Okay, so you can play around with these numbers. I have a very small screen, so it is not fitting. So I have reduced it to 0.55. So according to the screen dimension that you have, set it accordingly. So core is the first variable, which is the correlation matrix. X tick labels, Y tick labels are the X and Y axis names. V min and V max, they are the minimum and maximum values for correlation, -1 to +1. Annotation equals true means you will get the values inside the box. If you don't want, then you can suppress it by setting it to false. And then using the color, you can make out. Okay, darker color means high relation, lighter color means less correlation. So based on this, do we have any correlated variables? Look at all the dark ones. It's blank. That is because annotation is set to false. That's because you are taking the lower level. So this side and this side are the same. If you go from here, this and this are the same. So this column and this column and this column will be the same value. Okay. That's right. This side of the triangle is called lower triangle. This is upper triangle. So if you set it to 0, focus only on 0.
But when you are showing some colors, right?
Where are the blanks? You don't see any blanks.
Black.
That is okay. I mean, I'm not worried about the color. Let me see what else. Semester treatment for investigators, scholars, scientific scholars, freelancers, on daily basis.
We
Man's name. You know, man's name.
But it is showing this here.
Sure, I'm just not getting color.
You have also done the same mistake. Second minimum maximum is the same.
No, sir, I think
Minus 1 to plus. Within this minus 1, max is plus 1.
Very good. Generator of nine.
Well, sometimes with that small font, very difficult to make out. Now it is okay. Done? Tejas हो गया? -1 to +1. Correlation का range वही है ना? Increase the magnitude. ये dimension 12 by 10 है ना? उसको थोड़ा increase कर दो 18 करो या 20 करो.
18 का.
हाँ 18 करके देखो 18 by 10 is fine. Right or? Height चाहिए you can give 18 by 12 whatever now. Ankita done? Okay. Now, how do you interpret this diagram?
the mean value is highly negatively correlated with width.
So we have this minus 0.9. So this is minimum width versus width. Okay, so which is having a very high correlation, minus 0.9. High negative correlation. Okay, so we can get rid of either width or min width, any one. so that we don't have the correlation. Now, similarly, if you look at, और क्या है?
So there is 1.95, but it is not dark in color. So
0.95.
Median and mean.
Median and mean. Achha, 1 second. 0.95. But that is positive. Okay, look at the color code. Color code is when you have a dark color, that is negative correlation. When you have a light color, it is positive correlation. Dark brown, that is this point, is zero correlation. So this is positive correlation, this is negative correlation. So analyze this, and as part of the feature selection, we can build the second model and keep removing one feature at a time. Fine. Now I just want to find out the distribution of the classes. That is the y variable. So CTG dot NPS NSP dot value underscore counts. So we have NSP as the count is 1655, 295 and 176. क्या हुआ? Nish, what happened?
So the attribute error.
There it is NP dot you have you included the NP that is compiled? NP name. Import matplot elet.pyplot as NP. That is because NP is usually we use it with number. Like this is, I'm not saying this is wrong. Okay, it's very confusing. The NumPy library has a function called till. Okay, so here it is trying to find the TRI function inside pyplot, which is
Actually, I wanted to make it NP, but
so this you make it PLT. And here you use NumPy as the okay. Now this some languages are standard. For example, C bond is always SNS. But that doesn't mean that you cannot use any other value. But if you are referring to other materials, you will always find SNS. So that way it is easy for you to refer. Okay. So look at the distribution. What do you find? Severe imbalance, imbalance, or even distribution?
Imbalance.
There is an imbalance. Okay. So normal is the highest. Then suspect case is on the lower side. And the severe cases are on the lowest side. And this is how real life also is. Okay, if you take a sample of 5,000 people, you will find that majority of them are normal. Okay. Okay, now let's split the data into training and testing. Before you split. So Trainx.
Do we check for singularity in this?
You can do that. So that's what some columns are numeric, but they are actually categorical. For example, the values could be 0 and 1. So you need to do that analysis to find out whether there are singularities or not. Okay. So Trainx test X, train Y, test Y equals train test split. CTG dot drop. CTG dot NSP. So train data 1488 with 21 features. Whereas in the testing, we have 638 with 21 features. हो गया splitting तक? We'll take a break now. And after that, we'll do the model building, prediction, important features. and then do the random forest regressor. Okay, and we'll stop.
So random forest is the same as this different.
Similar.
It won't have that much, like, then I think it's strictly because it's not used because of the dog. So similar random forest.
We'll find out. Ankita, any questions from you? Are you able to make understand things?
Yes, sir. One question I have, why we have used trail function while plotting the heat map?
Sorry, repeat.
Why we have used trail function while while we are drawing the heat map?
Oh, trill function. Okay, okay. I'll explain that.
Because I have checked only with the correlation, the heat map is coming different.
See, okay, let me explain this with a simple diagram. So let us say that I have three features, okay? So I have a 3x3 matrix. So let's say I have three features, x1, x2, and x3. Now, if I plot this correlation matrix, is my screen visible to you?
Yes, sir.
Okay, so I have the first feature x1, then I have the next feature x2, and then I have x3. And similarly, along the columns, I have x1, then I have x2, and then I have x3. Okay, now let us assume that the correlation of x1, so the correlation of any value with itself is always 1. Okay, so x1 and x1 will always be 1. x2 and x2 will always be 1. x3 and x3 will always be 1, right?
Yes.
Now, let us say that I'm finding out the correlation of x1 and x2. So x1 and x2, so let us say it is 0.038. Okay, x1 and x2 is 0.038. And x1 and x3 is, let's say, minus 0.85. Okay, so I have the correlation of x1 and x2, x1 and x3. Now come to the second row. What is the correlation of x2 and x1? It is also going to be 0.038, isn't it? Because x2 and x1 is the same as x1 and x2. Right?
So in x3, it will be minus 0.085 or minus 0.8.
A bit louder, Ankita, I'm not able to hear you.
In x3, so the value will be minus 0.85.
Yes, so x1 and x3. So now this is x3, this is x1. So what is that value? It is minus 0.85. Now x2 and x3, what is the value? So let's assume it is 0.159. So x2 and x3 is that. How much is x3 and x2? So that is also going to be
0.159.
Now, if you look at this diagram, you will see that this along this diagonal, there are two triangles. This is the lower triangle and this is the upper triangle. Okay, so the value in the lower triangle and the value in the upper triangle both are same. 0.038 is here also, here also. 0.85 minus is here also, here also. 1.59 is here also, here also. Okay, now if I have a huge data in terms of the dimension, this may look a bit cluttered because I have the same value repeating. So in Python, there is a provision where I can take only one triangle into consideration and I can initialize the other triangle as 0. So that means if I take the lower triangle into consideration,
Okay. That's what the trail function
Yeah.
does.
So trill
It
function
will
is
take
the
the
triangle lower.
lower triangle.
So lower triangle means take this triangle to fill up the matrix. The upper triangle will have zeros.
0.
So that way it improves the readability. That is the purpose of using the trill function. Clear?
Yes, sir. Thank you so much.
Okay. Are you in Pune?
Yes.
Okay. So I have not seen you in the class. Are you not attending or you're planning to attend at some time?
Actually, due to a medical issue, I was not able to join.
Okay.
Uh,
So are you okay now?
yeah, feeling better.
Okay, okay. So can you enable your video for a minute? I don't know. I don't think I have ever seen you. So if your video is working.
1 second.
There you are. Hi.
Yeah. Hi. So due to medical issue, I was not joining through classroom. So that's
Okay.
why. But I'm
Okay.
joining all the classes from online.
Okay. So okay. So all the classes henceforth it will be online. Okay. But have you ever attended the classroom sessions before?
Yes, I have attended when the classes started. So when Lavis sir was teaching.
Okay. Okay.
Yeah.
So how was your learning experience with the previous faculty?
It was good, but some points I still not like. It was not clear to me also.
Okay. So now, is it okay now?
Yes. Yes.
Okay. And are you practicing?
Not much because I'm working also, so I get only this Sunday off. So
Okay.
I'm trying to make it more.
Okay. Where do you work, Ankita?
I work in a startup company,
Which
in
one?
leverage startup company. That's located in the Koraga Park, Energy Guru.
Okay. Okay. So that's your domain, energy.
Um,
Oh,
yeah, but I'm working as a data analytics already.
okay. 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 I see. Okay. So that's a 6-day working that you have.
Yes, till Saturday.
So are you able to manage with your health, office, studies, everything? I
So
hope
I'm
it's not.
trying. I'm
Okay.
trying.
Okay. 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 Yeah, I know it is tough, once your health affects you in some way, you really have to take care of your health first.
Yes.
So, and are you taking medicines or you're fit now?
Right now medicines are going on.
Okay, okay.
Some more days, yeah.
Okay, okay. And you stay close by to office?
Yes.
I mean, this institute?
Near Viman Nagar, yeah.
Oh, you are in Viman Nagar. Okay, okay.
So
Okay.
it is close by, so there's no much traveling. It's hardly 10 minutes. So that's how I'm managing.
Yeah, I know. I was staying in Koregaon Park earlier and my office was in Viman Nagar, Giga Space. Achha. So I am familiar with that area. I know that very well. So nice place actually. So nice to see you. I hope that we'll meet sometime in the institute.
Yeah, sure, sir.
Can drop down anytime, any of the classes. If you are feeling fit, you can drop in and you can meet your other friends also. Yeah, sure, sir. Sure. Okay. Thank you so much. Fine then. So fine, we'll continue in some time. I think they are still not back from the break. So maybe in about 5 minutes we'll start. Okay. So in today's session, all good? Yes. Yeah. Okay. All good. If you have anything, let me know. Okay. Not till yet. I'll let you know if I have any queries. Sure. Okay. Thank you. Fine then. Yeah. So let's continue. Yeah, thank you. Chalo, let's start. So now we will build the random forest regressor model. Sorry, classifier. Random forest classifier model. So we'll call this model as M1. Now, can you tell me what are the two main hyperparameters that we can tune in a random forest? Apart from what we have already done in decision tree. What are the two main things? Number of trees, correct. And number of features in each tree, okay. So this is random forest, okay. So I'll just put here as random forest classifier as RFC. Okay, so just make this change. Random forest classifier as RFC. Otherwise, I have to key in the full name. So RFC. Now the number of trees that I want is known as the N underscore estimators. So how many trees I want? Now the trees are based on two factors: number of columns, that is number of features that you have, and total number of records that you have. Okay. So as a as a starting point, number of trees could be roughly equals the number of features. So you can play around with that ratio. So if I take number of trees as 30, let's say. Okay. Or you can take the double. Because if I take random selection of features, chances are that two trees can have the same features. So you can maybe take a double, maybe 40, for example. So I want to build 40 trees. And in each tree, how many features I want. So that is given by this parameter called max underscore features.
Number of trees does not equal to number of attributes.
That is your choice. So this is what it. Decision tree, there was only one tree. Now I have 40 trees. Each tree will be a decision tree. And every tree will have a different set of features. For example, tree 1 can have the features. One second, let me. So for example, tree 1 can have the features LB and AC. Tree 2 can have the features DL and max. Tree 3 can have mode and tendency. So it's a random selection of features with replacement. So every tree will have two features, but the features could be different. But because it is with replacement, two trees can have same features. Okay, so this is something that you can start with an initial value and then decrease or increase based on the grid search.
So it is depending on random feature selection, right? So every time the predicted output or the precision is the way.
It can differ.
But if we want to keep those fixed, then how, like, we have to do it for standard case, and for which we have the maximum precision, we can consider that and keep it as
what do you want to fix? The features. So do the grid search. So start with 2, then take 3. Ideally, you should not have too many features in the decision tree. So maybe restrict your features till up to about 4, 2, 3, 4. So 2 features. See, sometimes if I have 2 less features. For example, 2 features, it may underfit. So start with 2, 3, 4, and then see how the performance is. Right? So I'm going to take 40 trees and 2 features. So here I'll put maximum features as 2. And other things, I'm going to take the default, that is minimum samples, all those things, which you can tune it later on and then fit into train X and train Y. So here you can put n underscore estimators equals number of decision trees to be built max features is the total features, total number of features I will put it. In each tree. Okay, now if I do M1 dot estimators underscore, you will see that it has built so many trees. Okay, since I gave 40 trees, so it is building 40 trees, and each tree will have 2 features, and every tree is distinct. Okay, look at the random state, they are all different. So these are the different trees that get built. So if you count them, you will see that there are 40 of them.
Picture is different in decision tree. All right. जो decision tree में जो feature रहते हैं, जो 40 में, तो similar रहेंगे या different रहेंगे?
अलग-अलग रहेंगे ना, हर एक ट्री पे अलग-अलग फीचर रहेंगे, पर 2 रहेंगे
क्या? Possibility नहीं रहेंगे क्या? जो feature है, जो पहले ट्री में और सेकंड ट्री में है.
With replacement है ना? Now we can do the prediction. So I'll call this predictions as P1. So P1 equals M1 dot predict on the test data, which is test X. Okay, so now we can evaluate the model. So first is the accuracy. So print model accuracy equals dot format. The function name is accuracy score. So this takes 2 parameters, the actual data, which is test Y, and predicted data is P1. So we are getting an accuracy of 92.9, almost 93% accuracy. Now, can we conclude that this is a good model based on accuracy? based on accuracy alone.
Yes. Yes.
Yes? No?
Confusion matrix.
Based on confusion. So confusion matrix will give you the precision recall data also. And overall, we have to find out whether the model is good or not. So the next one is confusion matrix. So PD dot cross tab. Actual data is test Y. Predicted data is P1. And then margins equals 2. This is actually not the right way to plot the confusion matrix. Okay, so you have to first do this PD dot data frame. What is the actual data? That is test Y. And what is the predicted data? That is P1. Okay, and then in the cross tab, you give the actual data, which is the column called actual, and then give predicted. Now, why are we doing this? Now look at the res.actual. Res.predicted. Okay, now why are we doing this? Compare this output, the first output with the second output. What difference do you see? Look at this output and look at this output. What is the difference?
Predicted and actual can be seen.
Predicted and
Actual values can be seen more clearly as compared to the first one.
the
Name of
the name. Okay, here in this one, I do not know which is the actual data, which is the predicted data. Okay, it simply says NSP and call 0. Okay, even I'm not saying this is wrong. Okay, you need to take some efforts to find out whether 506 is the actual data or 516 is the actual data. Okay, that is very easy to do. But if you look at this one, it clearly says actual data is the row and predicted data is the column. So now you see the actual class 1s. Class 1 is NPS. Okay, so 1 is N. So N predicted as N, how much? 492 out of 506. So how much is that ratio? 492 upon 506. Then 65 out of 88. What is this? Suspect case. Okay, this is N, this is S. And what is the value for the pathology? It is pathologic case 36 out of 44. So overall accuracy is how much? 492 plus 65 plus 36 divided by 638 true positives. And that comes to how much? 93%. Fine. So now let's look at the other scores also. So we'll verify whether the values for N is so much, S is so much, and P is so much. So 492 upon 506. So we can 97. Okay, so let's do that. So print classification underscore report. Res dot actual. Res dot predict. So now you can see class 1, 97%. Class 2, 65 divided by 88, which is 74%. Class 3 is 36 by 44, so roughly 80, so 82% recall. Now, the weighted average is 93%. The individual classes are 97, 74, and 82. Now tell me whether this is a good model or not. So this is accuracy, this is recall. Good model. Okay.
But for S, the precision is 0.79.
So that is the reason why the recall value is also on the lower side. So I want everything to be on the higher side. So preferably 85%. So how can we make, so model 1, the normal getting predicted as normal is good. People who have the disease predicted as having the disease predicted good. But the suspect case, this is where we have the false positives. And this is the most dangerous thing. Okay, so this 74, if some way I can improve this accuracy from 74, try to pump it up to maybe around 85. Okay, so how can we do that? Correct. So we'll do the feature selection. Okay, feature selection can be done in multiple ways. Number 1, we have already done one using the heat map. So reduce the number of multicollinearity. So that is one kind of feature selection. Second type of feature selection is using the singularity concept. We have not done that. So do the singularity. Third one is finding the important features from the model, which we did in decision tree. Remember? So we'll do that now. Important. So first method is heat map. Second one is singularities. So we have this method called feature underscore importances underscore. Okay, so this is going to give you a score for all the features. Okay, so we'll put them in a data frame where one column will be the feature name, the other column will be its corresponding score. So the sequence of this is based on the columns. Okay, so it's a one-to-one mapping. So we can call this as data frame of, we can call this as feature underscore scores equals pd dot data frame. Now we have already stored our data, the list of columns in the variable called calls. So we'll use this same name. And then the score, we'll take it from this one. Then print df underscore feature underscore scores. Okay, so here it is going to list out all the features and its corresponding scores. Higher the score, more significant is that particular feature. So what we can do is we will sort the data according to the score in the descending order. So df. So df underscore feature underscore score equals df underscore feature underscore score dot sort underscore values. So sort the data based on the score in the descending order. So I'll give ascending equals false. Now you can find out which are the top, let's say I want the top 6 features. So what are the top 6 features? So ATLA, TLV, ASTV, mean, median, MSTV, and min. So look at the score 0.11, 0.09, 0.08, and then it is reducing. And the least significant feature is DS, which is having a score of 0.001. The numbers may differ because we have taken random selection.
Sir, can we speak about singularity from this data? Output we have got.
Which output?
So
Scores
like here, DS is like 0.3 significant. And in the data set itself, it has many zeros.
So find out. What is the data called concrete? No, sorry, not concrete. CTG dot DS dot value underscore counts. Very good. So it is a clear case of singularity. So DS can be removed. So is this a categorical data or is this a numeric data?
Yeah.
It looks like a category. Okay. So here you can see that out of 2200, sorry, 2001, whatever number, almost 90% of the data, more than 90% is having the same value. So this is singularity. So remove the feature DS. Ankita, any questions? Okay. Done? So we can, instead of calling feature, Now what you can do is for the next model, you can remove one feature at a time. You can remove the multicollinearity, the columns that is multicollinear, remove any one and try to build the next set of model and try to change the number of trees, try to change the number of features and include the other hyperparameter tuning, other hyperparameters applicable to decision tree, that is the samples. Okay. Also, you can use the CCP value. So when you keep introducing all these things, you will see that the code actually becomes bigger and bigger. Okay. So you do this exercise and you can try it out later on. I just want to finish the decision tree regressor also. And after that, you can do your the learning, the exercise that you have in your portal. Okay. One again.
Decision tree regressor or random forest?
Random forest regressor. Decision tree we did yesterday, isn't it? So you will use the same file, just copy paste it and put it under random forest. So we'll compare all the three models. Any questions? Tejas? Ho gaya? No, it is a classification problem, isn't it? Yesterday we were doing this, the file on decision tree. So take the same file and just include this line. From sklearn.ensemble, import random forest regressor. Okay, data set is going to be the same concrete. So here I'll just put the comments. Regression using OLS, DT and random forest. So pandas, numpy, stats models at API is for the OLS model. Then mean square error for the evaluation. Decision tree regressor. We saw this yesterday. Model selection train test split, and then from sklearn.ensemble random forest regressor. So compile this. Now you can put as random forest regressor. Okay, then read the file. So this is my file where I'm going to predict the value for CCS, compressive concrete strength. Then change the column names. Then the Y value is CCS. Okay, same code that we had yesterday. I'm just executing yesterday's decision tree code. Okay. Then splitting the data into X and Y. That is train X and train Y. And then building the model. So here, in yesterday code, we had only two models, M_LR, M_DT, correct? Now we'll include one more model called M_random forest. And here use the random forest regressor. So give RFR. And if you want, you can give minimum samples. Sorry, not minimum samples, max features. And you can also give the estimators, how many trees that you want. So let us take 20 trees and we'll see how the result is. Okay, now build all the models, linear regression model and decision tree model. हाँ, कल का जो डिसीजन ट्री का जो कोड था ना, सेम है वो, no change. The only extra thing that I'm going to add is this line number 57. This is the random forest regressor. हो गया? ठीक है. Go till the model building part, then you go to the next. First, import the library random forest regressor. That's this one. Yes. Model building हो गया? All the three. Have you spread the data? This is the function, isn't it? When I follow the description. You have to call the function only then you will get this output, isn't it? After this, insert the cell on this. So do till the model building and tell me. Uske baad we'll do the predictions and the analysis after that. So do till line number 57. Yahan tak ho gaya, let me know. Done? Manish, done? Tejas? Ankita, is it, have you finished? Okay. Done? Okay. Now let us do the predictions. So once again, I'm taking yesterday's code and adding the code for random forest. So P underscore LR is for linear regression, P underscore DET for decision tree. The extra line that I'm going to add is P underscore random forest predictions, and the model is M underscore RF. Now I have the 3 predictions from 3 different models. Now we will see which model is the best. So here we have the MSE of the 2 models to make it MSE of the 3 models. And I think we have a function called MSE. वो function है MSE. So I think I have accidentally removed. So I'll just add that. हाँ वो कहाँ पे है वही मैं देख रहा हूँ. इसके नीचे है क्या? Yeah, but I'm not able to see it.
So it should be around 60 to 65.
Okay, I'll just write it. Get error. क्या था वो get error parameters? Actual and pred. Okay. So MSE equals mean squared error actual and pred. C equals NP dot SQRT MSE. I think it was rounded off, no?
Yes, sir. To 4.
Return.
Sir, 972 we require the round again.
No, I have to remove it.
Okay.
Underscore LR. Okay, so the MSE of the three models. Now I can print the RMSE of the three models. So RMSE / TLR decision tree equals this /n / t. Random forest equals this. So this is RMSE LR RMSE DT RMSE random forest. So now look at the result and tell me which is the best model.
Random forest.
Okay, according to the result, it is random forest. Okay, now we will see the actual values versus the predicted values. So now we'll store the results in the data frame. So LR prediction, decision tree prediction, and we will also have the random forest prediction. And this is P underscore random forest. And now look at the values. Now see, Now what difference do you see in the predictions of decision tree and random forest? ये वाला दो ब्रैकेट एक ब्रैकेट Ankita, have you finished with the 3 models? Okay, now look at the predictions. So let's explore let's look at the first record and third record. So 913 and 257. Now, what is the actual value? 35.86 and 42.55. What is the OLS output? 37.63, 32.17. What is the decision tree prediction? 35.22, 35.22. And what is random forest prediction? 37.22. Sorry, 32, 39.74. Now see the difference. So what has happened here? Decision tree has actually classified it based on the path, whereas random forest, because of lesser features, this has done a single value prediction and not a classifier. So this is behaving a much better prediction compared to decision. Do you see any values repeating in random forest? So sort करके देखो. So df underscore results dot sort underscore values based on rf underscore spread, random forest spread. Okay, there is hardly any repetition. But look at the decision tree. 13.06, 13.06. Everything is getting classified as the same number. Look at this. Whereas for the same records, look at the prediction for OLS and look at the prediction for random forest.
I have got some repetitions in random forest.
Okay. Now look at the actual value for that. Is that also repeating? Because actual value also has some repetitions.
Yes.
See, there could be 1 or 2 records repeating because this is also a decision tree. Okay.
Yes, sir, the actual values are repeating, so this random forest.
So can I conclude random forest is the best model here?
Yes.
Yes. Okay, so I've just done a very basic implementation. Okay, you have to put the other things in place, EDA and all that. Okay, feature selection, then do the complete stuff. So that completes random forest algorithm. So by next week, we should be able to wrap up supervised learning. Next Sunday tak. You can also draw the line, the best fit line. So I did not do that. So you can run these 2 lines as well. Look at the dots, look at the points. They are very close compared to the other ones. So that's why we're getting this RMSE as 5.3. What is the ideal RMSE or MSE?
5%.
Do we have any ideal value for RMSE or MSE? It should be very close to 0. Okay, so you can try your LMS assignments on random forest. Do it now. We have lots of time. And if you have any questions, you can ask. Online, Ankita and Manish. So, Ankita, have you finished? Okay. So you can start with your online, your LMS assignment and try to finish it today. We won't be starting anything new today. Okay. Fine. DF underscore S. It's not DT there, it is spread underscore. छोटा फॉर्म दिखता है इसमें प्लेस होल्डर भी डालना है यहाँ पर ये डाला है प्लेस होल्डर ये तो वेरिएबल है पर ये कहाँ पे जाएगा
There are only 3 results here.
5. OLS, decision tree, random forest, support vector machines, and KNN.
So for support vector machine, KNN will same data as engine, right?
We'll use the same, or if you want, we can use a different one also. The idea is the same. Again, SVM and KNN, they are mainly used for they are mainly classifiers.
import read result import नवीन वाले डेटा सेट इंपोर्ट केला म्हणजे जेव्हा ऍक्च्युअली रिझल्ट केले एक पण नाही मग ते मला बेनिफिट सेमच आहे रँकिंग आहे ना तुम्हाला सगळ्यांना सेमच आहे एकच टाइम वाला ड्रॉप करेगा यूनिक पण आहे टाइम ड्रॉप होईल साइड ड्रॉप होईल आम्हाला मी काय प्रेडिक्ट करायचं तुम्हाला काय Certificate में हम तो स्क्रीन क्या करूँ मैं बिजनेस वाले पढ़े
45 modules entered and completed. Feedback only.
सात नंबर I
Drop their amount by amount explain prediction माझा असं नाजूकपणे हँडल करते ऑफिस नाही काय स्लो चालतंय
आता तुम्हाला सगळं कॉन्फिगरेशन काय वापरतात तुमच्या फील्डसाठी तेवढंच
त्याचे आपले आई पाहिजे हाय प्लस आणि त्याची हिची साईज आहे ना अशी एवढीच आहे मला माहिती नाही पण हे जे आपली त्यांची साईज आहे ना नाही ते खूप प्रॉसेसर खूप जास्त पाहिजे मॉडेल डिप्लॉयमेंटसाठी त्यामुळे फक्त त्यांनी थोडे असे आणि ते नाही ते डिपेंड असतं Training platforms, modern training platforms.
In our office,
Right somewhere.
office server office network. Local
So electricity generation
मी फॉर्म भरतो TCS ला दरवेळेस एरर येतो खाली बुक समथिंग अँड रॉंग भरता जर नाही मी मोबाईल सोडले जाऊ दे दुसरीकडे
I say the second we are latitude the one which is on the next allows for the taxi like prediction. So we have so we can drop that, right? Drop the data, so because it is not time series.
Find out this useful or not.
How to work with this data?
Yeah.
This is the data.
क्या करना है इसमें?
Predict करना है. Second column.
Oh, second column. Okay, it's a regression problem.
Regression is a random forest. Because they are regressive.
Are you sure? Predict करना कि number of passengers predict करना?
नहीं, taxi fare prediction.
Taxi fare prediction. So you have unique ID. Okay, date time of pickup. See, यहाँ पे date time will be important. You know why?
taxi rate.
Correct. Taxi rate.
Okay.
So you need to think of the logic where have you used Uber before? So based on your experience, you go from A to B. It's same location but different times. They change location. So what makes that? Time.
Time.
So इसीलिए यहाँ पे date time of the pickup is.
Daytime
So you need to think of that logic. Which part of the time? Early morning, late afternoon, late evening, late night.
And the time range, say from morning 7 AM to 11 AM. Maybe the afternoon
you can have it as early morning. Okay, let's say 5 to 8. We want to have it as long peak, 8 to 11 peak. So what category you can do? Peak. One category is peak. So accordingly you have that.
then we will be dropping.
Then this category, right? Then this is not leaves. Latitude and you need to think of logic. Take and not able to recognize that naam yaad nahi aa raha, but this can be converted to distance. Take care.
So we will do this changes in Excel or in Python.
Python. Don't touch the data once it's lost. Everything will come. Any changes that you want to do it in your machine. This all in advance. Just try to recollect that algorithm का एक नाम है. क्लासिफिकेशन में कुछ नहीं है. रैंडम फॉरेस्ट क्लासिफायर, नो असाइनमेंट्स. यही है तो ठीक है.
It is point test function. Point test to convert latitude to longitude into distance.
I think so.
Simple one, they are taking the coordinates and then distance. Point test.
I actually wrote the code. To use this, try it out. One again is 3 camera. It's 3.
Import H3. Then import H3.
Oh, that is a library that was
H3.
Again, you try this, but we do this.
Haverson.
Haverson, right? Haverson business. Haverson. I have the code with me. Just look for any library in Python. Haverson, the R pe it has.
Import Haverson pitches.
है क्या? Then use that. Able to find it. I think it's in my other laptop. You want to break early?
Yeah.
Or you want to start late? क्या करना है? नहीं अभी जाना है या want to wait till 1:15? कर लेते हैं ठीक है. नहीं if you कुछ discuss कर रहे हो then you can stay back. You want to leave or stay? भाई कुछ.
Will you, sir?
Okay, fine.
We'll do this. We'll just try to do this, but I'm not sure how. Because that conversion or this.
So this looks a bit of some complex.
Sir, like.
अरे एक एक करके पूछो. Let's finish that question. Conversion of what? Yes, that is one.
Second one is date time to category.
Correct. You need to do these two.
So converting date time to category, like from this to this.
You have to write your own function for that.
Converting it. So input to पूरा column देना होगा. That function.
पूरा column नहीं है. You write that function and input will be every value of the column.
Every value.
Because every value will have a certain date and time, not date, time. Here the input will be more on the time rather than the date or the date.
Then it will be writing unitary function, right? Like if date that particular or column ranging between this and this, then else then print so else.
Print नहीं करना है. You have to assign a value. You will create a new column, and then based on the condition, you will either put the whatever value. Let's say that you are going to have 4 values. Okay, off peak, peak, whatever it is. Okay, or early morning, morning, evening, night. So accordingly, you can assign the value for that particular row, and then do it for all the records, and then remove the original data. That is your date column. Yes, yes.
Then again, we other columns are in numerical. Then we have to convert those
Dummies.
numerical. Case by double.
Yes. Correct. Second is conversion of latitude, longitude to distance.
That will be anyways the number, so no need to convert anything. Then we can drop that latitude and longitude.
You have to.
If we have.
So I was telling him what is GitHub.
Sanna, you had a question, no? You were asking.
No, sir.
No?
I thought we could solve it in the class. It's very hard.
In class where sometimes you need the time to think and do it. Sometimes you can do it much better at home, relax and then do it.
I think you were saying you help us to solve this, right?
I will assist you. I mean, guide. Abhi ye likho, next line do this thing. Not that sort of thing. So when will you learn? Fine then. So we'll leave early today. And we'll catch up on the next week. We'll meet. So online, Ankita. So we'll meet on Saturday. Try to finish all your assignments before then. Okay. So have a good weekend and have a good week ahead. See you on Saturday then. Bye.